All right, Math 2 3.9, factoring higher degree functions. So let's look at, we talked about difference of two squares in a couple of videos ago. So if you have something where you have x squared minus, there's where the difference is, and then something squared, we'll just put y squared. If you have something along the lines of that, and you can put them both in parentheses, then you can always say, well, you have x plus y, x minus y. It will always factor out to be that. So what we're going to do in these first problems is we're going to try to rewrite it to where we have parentheses with a square in it. Okay? So number one, we want it to look something like this. Right? The 25 will be easy. 5 squared gives me 25, right? Now for the 4r squared, we have to look at them separate. The 4 is a 2, and the r is just plain old r. Right? So let me rewrite this. The 4r squared, that's where this guy is. And then the 25 is there, and then here's our minus sign. Now, this looks a whole lot like our formula that was up here. So we can now rewrite this as 2r plus 5, 2r minus 5. And we can't factor that anymore, so that's where we're done. Okay. Number 2, same plan. We need to rewrite it as something like this. We have another 25, so we know that's going to be a 5. We have 9, so I think we know that that's going to be a 3. The n to the 4th, well, we have n to the 4th, and here we have a square. So inside it, we're going to have another n squared, right? Not an n to the, just a plain old n, we're going to have n squared. So we have 3n squared minus 5, 3n squared plus 5. Oop, let me finish that parenthesis. There we are. Number 1 and 2 are a whole lot alike. The big thing that's different about number 1 and 2 is that exponent here, the square versus the 4. Number 3, same idea. 9 we know is going to be a 3. 16, well, the square root of 16 is 4. B to the 6th. Now, if you have something b to the a to the b, then that's equal to b to the a b. You multiply them together. Okay? So we have a 2 here. That's where like our b was there. I guess I probably shouldn't use a b there. Maybe we'll use a c. So there's a 2. That would be like our c. And this guy here would need to be 6. So it would make sense that the a would be a 3, because 3 times 2 is 6. So this is going to be b to the 3rd. Okay, and now that we've got that hard part of the problem done, we can just rewrite it in the formula. 4b cubed plus 3, 4b cubed minus 3. There we are. Okay, number 4. Now it gets a little bit different. So normally, well here, let me rewrite this. If we had it written as y squared plus 3y minus 40, we would know how to solve that, or we would know how to factor that, excuse me. So what we're going to do here is we're going to start off by making the problem easier. We're going to say, well, y equals x squared. And we plug in for a y where we have an x squared or next to the 4th, right? So that makes the problem a whole lot easier, and then we can factor it like we would any other quadratic, and then we can at the end plug back in what our x is. So now that we have this step here, we can factor it. We need factors of negative 40 that add up to 3. We've got, what is it, 5 and 8. 5 times 8 is 40. those can add up, those can make a 3. It needs to be a positive 3, so I guess it's going to have to be a negative 5, right? Because 8 minus 5 is 3. So our next step is going to be y plus 8, y minus 5. Now that we've factored it, we need to plug back in our x squared. So we're going to say, well, this is the same thing as x squared plus 8, x squared minus 5. And at the end of these problems, we want to check, can we factor this again? And so the spot where we would be able to factor it again, if we could, would be the second term with the minus, x squared minus 5. So we want to check, is that a difference of 2 squares? And the answer is no, because 5 is not a perfect square. So we're done. I believe there's going to be a problem where we can factor it again. It'll make more sense when we see that. All right, continuing on. I don't really know what my OneNote app did, but it messed up all the problems on the back page, so I had to pause and correct those. All right, number 5. So again, we can say, well, y equals x squared, which would say, well, this is the same thing as y squared plus 4y plus 3. We take factors of 3. Well, that's 1 and 3. That's all that we can do. But it turns out that they add up to 4, which is really nice. So we can say, well, this is the same thing as y plus 1, y plus 3. And now that we can't factor anymore, we need to plug back in our x's. So we have x squared plus 1, x squared plus 3. And that's it. All right, number 6. For starters, we can again plug in y. So we're going to have y equals x squared. And if you're able to do the y step in your head, you're welcome to do that. I think that it's helpful sometimes, especially in the beginning. So we have y squared plus 7y minus 8. We bring our 8 over here and we factor it apart. We have 1 and 8. I'm trying to make a 7. I mean, you could also list the 4 and the 2. But I don't think 4 and 2 can make a 7. But 1 and 8 can. We need a positive 7, so it's going to be a negative 1 and a positive 8. So we're going to have y minus 1, y plus 8. We can plug in our x, so we get x squared minus 1, x squared plus 8. Now we need to check, can we factor again? And the answer is yes in this scenario. The way that we're able to factor again is using this x squared minus 1. Well, this is the same thing as saying x squared minus 1 squared. You could write it like that. So if you just look at the highlighted stuff here, it's like problem number 1 on this notes, where you could rewrite this as x plus 1, x minus 1. So this highlighted thing, those are equal. Now, whenever you go to type in or go to CUDA-Works to do the homework assignment, the order of these 3 guys might be different. So like you have 3 guys, 1, 2, 3. You can reorganize those as much as you want. This is the same thing as like if you said 2 times 3 times 4, you could rearrange that into 4 times 2 times 3, right? It's multiplying, so you can just rearrange them. So on CUDA-Works, they might not be in the same order that you find them, but as long as the 3 terms are there, you're good. All right, number 7. Well, we can start off by plugging in a y. Y equals x squared, so we'll say, well, this is 14y squared minus 118y minus 72. Now, we have the 14 hanging out front. We need to try to get rid of it as much as we can. So let's see, can 118 divide into 14? And the answer is no. Everything is even, so let's try taking a 2 out of it. So we're going to have a 2 and then some big parentheses with everything in it. Since we're factoring, and since there's no equal sign, we need to make sure that we keep that 2. We can't lose it. So we're going to have 7y squared minus 56y minus, is that 36? What is that? 36. All right. Now, there's two ways to go about this now. You could either slide and divide, or guess and check, or just guess. Okay? I'm going to show you this, I'm going to talk you through how to guess it, but I'm also going to show you to start off how to slide and divide. Now, sliding and dividing is a special way to factor whenever you have something in front of your quadratic term in the front. So what we do is we're going to take this 7 and we're going to slide it over to the negative 36. And we're going to multiply them together. So we're going to have 2y squared minus 56y minus, I don't know, what is 7 times 36? 252. Now we want to try to split up the 252. We're going to keep solving the problem like normal now, and then at the end we'll have to divide, and I'll show you what I mean. 252, you could divide it by 2 and you'd get 126, but there's no way to make a 56 out of those two numbers. Let's try a 4. 4 and 63, can we make a 56 out of that? And I'm thinking 63 minus 4. Well, that doesn't make sense. Oops. I was thinking it was the 4. This is not supposed to be 56. I'm sorry. It's supposed to be 59. I messed up there. I apologize. All right, so that means that the 4 and the 63 do work. It's going to be a positive 4 and a negative 63. So we're going to have 2 out front still. Y plus 4, y minus 63. Okay, now is for the divide part. So we're going to need to divide by whatever we slided by. So we slided 7, so now we're going to have to divide 7. You divide 7 into both of these, 4 and the negative 63. So let's rewrite this. 2y plus 4 over 7. And then 63 divided by 7, I think, gives me an actual number. 63 divided by 7 gives me 9. Now, we don't like having this fraction here. So if you do the slide and divide and you end up having a fraction there, put that 7 or the denominator in front of your variable. So you're going to have 2, 7y plus 4, y minus 9. All right, we're done with the slide and divide stuff. Okay, to finish off, I'm going to pull this up here and let's plug it back in our x's. So we have 2, 7x squared plus 4, x squared minus 9. We need to check, are we done? Are we able to factor anymore? And the answer ends up being yes, because we have x squared minus 9. This is the same thing as x squared minus 3 squared, so we can factor that apart. So we have 2, 7x squared plus 4, x plus 3, x minus 3. And now we are finally done. All right, there we are. I am going to go straight down to number 9 now. So let's start off by seeing if we can pull anything out. I think we can pull out a 2, so let's pull out a 2. We're going to have a 2, and then we'll have 6. And let's go ahead and put in a y. Y equals u squared. So we'll have u squared plus, what is this going to be, 33u minus 120. Is there another number we can pull out? Everything's a multiple of 3. Let's pull a 3 out now. So we're going to have 2 times 3. We'll have 2u squared plus 11u minus 120 divided by 3 is 40. All right. Now, to go about this problem, say we wanted to do the guess and check method. We have our 40, and we want to try to split it apart. And I'm just going to list all the factors because, I don't know, it just makes it a little bit easier for me. So I have 1 and 40, 2 and 20. 3 doesn't work, 4 works, 4 and 10. 5 and, is it 8? Yeah, 8. I don't think 6 works. 7 doesn't work. 8, oh, we're back. So those are all of them. So what I'm going to have to do is I'm going to have to make 110, and I have to multiply one of the numbers by 2. Now again, right now we're just doing the guess and check method. If you like doing the slide and divide, I'm going to do that on the next problem. But I just wanted to show you what I do with the guess and check. So we need to somehow make 110 out of these numbers here. I am not seeing it. Oh, good grief. This is not a 110, this is an 11. There it is. Okay. So we've got 6, we could do 5 or negative 5 plus 2 times 8. That's negative 5 plus 16, which is 11. There we are. So I'm going to have 2 times 3 is 6 out front, right? That's where that went. Then I'm going to have my 2 sets of parentheses. One of them is going to have a 2. Over here I said 2 times 8. So my 2 and my 8 cannot go together. So I'm going to have to put my 8 over here, right? Because my 2 is over there on the left. And then over here I have the negative 5. All right. The guess and check can sometimes be a lot faster, but sometimes it can be a lot slower. What I would do if I was you guys, I would try to guess and check. And if it takes over, I don't know, 3 minutes, go do the slide and divide. Oop, I need to put in a, oh good grief, I messed this up. All these U's, I was supposed to put in a Y. I'm sorry. I'm looking back up here and I'm correcting myself. So this is supposed to be a Y, here's supposed to be a Y, this is a Y squared still. So this is supposed to be a Y, this is supposed to be a Y, and now I need to put back in my U's. So 6, 2U squared minus 5, U squared plus 8. There we are, okay. Oops. All right, that looks better. All right, finally, we are actually done with number 6 now, or number 9 now. Number 10. Okay, I want to start off by factoring things. I'm going to pull out a, I don't know, can I pull out a 5? No, I can pull out a 2. We'll pull out a 2. So I'm going to have 2, 5x to the 4th minus 13x minus 6. All right, I'm going to really quick see if I can guess and check. So 6 is 2 and 3, 1 and 6. Could I make a 13 out of this? I think I could. Well, I know I have to be able to. Yeah, I could do 5 times 3, negative 5 times 3 plus 2. That gives me negative 13. So that's how I would do that. But just because I want to show you is the slide and divide. So we're going to slide the 5 over. So we have 2. And I'm going to change this into a y squared minus 13y minus 30. I can split up into 5 and 6. And I'm thinking 5 plus 6. Nope, it isn't. How about 10 and 3? There we are. A negative 10 and a negative 3 gives me negative 13. So I'm going to have 2 y minus 10, y minus 3. Now I did the sliding up here of the 5. Now I need to divide the 5, so I'm going to divide both sides by 5. Ten divided by 5 is 2. 3 over 5 just stays 3 over 5, so I have y minus 3 over 5. I'm going to put back in my x's, and also we have to remember that if you have a fraction at the end, that 5 needs to go with the variable. The denominator goes with the variable. So I'm going to have 2, I said I would put my variable back in, so x squared minus 2, 5x squared minus 3. All right, there we are. Finally, we are done.